You may wonder why it is so important to simulate boiler failure conditions in this application. When developing software that acts as a simulation model for hardware, it is important to simulate failure conditions. Boiler.vi is a software model that you will eventually replace with code that interacts with real boiler hardware. Real hardware can malfunction, so it's important to test how your software is going to react to those malfunctions.
Sandwich testing is a combination of both top-down and bottom-up integration testing. It uses top-down tests to test upper-level control and uses bottom-up tests to test low-level hardware and system functionality. It combines the benefits of both top-down and bottom-up testing.
In the sprint planning meeting for this iteration, the product owner chose to implement the user story that describes the process for safely shutting down the boiler. To implement this user story, your team identifies the following development tasks. To accomplish these tasks, your team decides that 2 code modules are needed, Shutdown Controller and Purge Complete. Your team has already implemented and tested the Purge Complete functionality as part of the Start button functionality. To test the Shutdown Controller code module, your team decides to use sandwich testing, since that approach provides the benefits of both top-down and bottom-up testing. When the user clicks on the Stop Boiler button, the event handling loop sends a shutdown message to the message handling loop, which sends a shutdown message to the boiler controller. The boiler controller then implements the shutdown in 2 phases, Shutdown Controller and Purge Complete. During the Shutdown Controller phase, the boiler controller sends a reset message to the boiler. Once the boiler responds that it has reset, the boiler controller sends a message to update the user interface. Next, the boiler controller sends messages to the boiler to turn off the forced draft fan, set the fuel level to 0, and set the flame level to 0. Once the flame level reaches 0, the boiler controller sends messages to the boiler to turn on the primary fan and turn off the run interlock. The boiler controller then writes an update to the status log and updates the user interface. The primary fan runs for 2 seconds and then the boiler controller enters the Purge Complete phase. During the Purge Complete phase, the boiler controller sends a message to the boiler to turn off the primary fan. Once the boiler responds that the primary fan is off, the boiler controller updates the user interface and writes an update to the status log. Let's take a look at the Stop Boiler functionality that you're going to implement as part of this exercise. When the user clicks Stop Boiler, a number of things are going to happen. So let's talk through those things before we actually click on the button. On our boiler, we're going to see that the Simulate Failure button is going to be disabled, and we're also going to disable the fuel control valve and the stop boiler controls on our boiler controller UI. We'll also see that the status indicator is going to change to indicate that the boiler is shutting down. The pilot flame level is going to start decrementing from 100 down to 0 over the course of 2 seconds. When the pilot flame level reaches 0, the forced draft fan LED is going to turn off on both the boiler and the boiler controller. The status indicator is going to change to indicate that the boiler is entering a purge cycle, and the primary fan is going to turn on for both the boiler controller and the boiler. After 2 seconds, the primary fan LED turns off, the reset button will be enabled, and the status is going to change to indicate that we are in a lockout state. So let's see all of this in action. Here we can see our pilot flame level decrementing. We're in a shutdown state. Our primary fan LED turns on for 2 seconds, then it turns off, and we're in our lockout state. The reset button has been enabled. Our UIs now match the state that they were in when we first started the application. And in fact, we can restart the boiler now and walk through the entire cycle again. Now, instead of clicking on Stop Boiler to shut down the boiler, I'm going to go instead and click on the Simulate Failure button. Here you see the exact same behavior. Our pilot flame level decrements, we're in a shutdown state, primary fan turns on for a purge cycle, and then we enter the lockout state. Now let's take a look at our status log. Here we can see that we've added a couple of new entries, where we're starting the shutdown purge, and then we indicate that the shutdown purge is complete. In this exercise, you will perform sandwich testing as you integrate the stop boiler functionality with the rest of your application. Let's take a look at the solution to exercise 6.5. When the user clicks on the Stop Boiler button, we send a shutdown message to our message handling loop. From there, we send a shutdown message to our boiler controller. In our boiler controller, when we go to the shutdown case, you can see that we've broken this functionality into two pieces, shutdown controller and purge complete. First, let's take a look at what happens inside of shutdown controller. First, we send a reset message to our boiler so that it will disable the simulate failure button. Then we update the user interface to indicate that the boiler is shutting down. Then we shut down the boiler. We'll come back to what this functionality does specifically in just a moment. Next, we write an entry to the status log and we update the user interface to indicate that the shutdown purge has begun. We then wait for the purge process to complete. The duration for this purge was read from the INI file. Now, let's take a closer look at the shutdown boiler functionality. Here you can see that we send messages to the boiler to turn off the forced draft fan and to set the fuel level to 0. We then update the user interface to reflect those changes. Next, we send a message to the boiler to set the flame level to 0, turn on the primary fan, and turn off the run interlock. Once the purge time has elapsed, we're then going to enter the purge complete code module. So let's take a look at that functionality. This VI is going to send a message to the boiler to turn off the primary fan. The boiler controller then updates the user interface to indicate that the primary fan is off and the boiler has entered the lockout state, as indicated here. The boiler controller also writes an update to the status log that the shutdown purge is complete, and it includes the duration of the purge cycle. Now let's take a look at how we are updating our user interface based on these various changes. So let's go take a look inside of Update Display, and we'll open Update Controls. When we go to the shutdown case, you can see that we're going to then disable the fuel control valve and the stop boiler controls. During purge, there's no specific action that we're going to take. Then, when the purge cycle finishes, the message handling loop status is changed to indicate lockout, which is where we enable the reset button so that we can restart the boiler. Now that you have tried all three approaches to integration testing, you might find yourself wondering when sandwich testing would be the best approach to take. Sandwich testing is most valuable for very large applications where testing purely from the top down or from the bottom up is impractical. The architecture team can start testing from the top down. The code module teams can start testing from the bottom up.
You have completed this lesson. Here's a summary of what we covered.